Imagine you buy a state-of-the-art computer. You take it out of the box, and the manufacturer tells you that from this very moment, the hardware will only degrade. The processor will inevitably slow down, the memory banks will fail, and there is absolutely nothing you can do to stop it. For decades, that is exactly how modern science conditioned us to think about the human brain.
Hmm. It is a remarkably bleak perspective when you frame it like that. The established scientific dogma of the 20th century was that the brain was essentially a finished, rigid machine by the time you reached adulthood. The consensus was that you had a finite number of neurons, and as you aged, they simply died off. Memory faded, plasticity collapsed, and cognitive deterioration was viewed as the unavoidable tax of simply staying alive.
But what if that entire narrative is fundamentally flawed? What if the aging brain isn't a degrading piece of hardware at all, but rather highly adaptive biological software? Today, we are dismantling that old, limiting belief. We are diving deep into the emerging science of neuroplasticity and neurogenesis to uncover how the brain can actually regenerate, rewire, and evolve well into our 50s, 60s, and beyond.
The implications of this scientific shift are staggering. Because if the mind remains programmable deep into later life, it begs a fascinating and somewhat uncomfortable question. Are we actually losing our cognitive edge to time? Or are we just living in modern environments that actively suppress our brain's natural ability to renew itself?
That is the exact question we need to unpack. Let's start with the foundation of this neurological revolution, neuroplasticity. For the longest time, the academic consensus was that once neural pathways were laid down in childhood and adolescence, the concrete dried. But it turns out the concrete never actually dries, does it?
Not at all. Neuroplasticity is the brain's lifelong capacity to reorganize itself. Every single habit you form, every new piece of complex information you learn, and even the recurring emotional states you inhabit physically alter the microscopic structure of your brain. It is constantly remodeling its synaptic connections based on your daily experiences.
So it's less like a static architectural blueprint and much more like a bustling dynamic city grid. If a road gets blocked by construction, the traffic simply reroutes. And if a particular pathway is used constantly, the city upgrades it from a dirt road to a 10-lane superhighway.
That is a brilliant way to conceptualize it. And the most mind-bending part of this adaptability is a process called adult neurogenesis. We used to think you couldn't grow new brain cells once you reached a certain age. Now, research heavily suggests that specific regions of the brain, particularly the hippocampus, may continue to generate entirely new neurons deep into adulthood.
And the hippocampus isn't just some random area, it is the absolute epicenter for memory formation, spatial navigation, learning, and emotional regulation. The fact that this specific critical region retains regenerative potential completely flips the script on aging. We aren't just slowing down the loss of old cells, we are actively capable of minting new ones.
Exactly. It completely redefines human cognitive potential. But there is a significant catch here. Just because the brain has this incredible regenerative capacity doesn't mean it operates in a vacuum. The brain is exquisitely responsive to its environment, and frankly, the modern environment is incredibly hostile to neuroplasticity.
Hostile is the perfect word for it. We are looking at a modern epidemic of chronic stress, severe sleep deprivation, digital overload, and highly sedentary lifestyles. It makes me wonder how much of what we casually dismiss as normal cognitive aging is actually just the accumulated damage of a lifestyle that starves the brain.
A massive portion of it. Take chronic stress, for example. When you are constantly stressed, your body pumps out cortisol. In short, acute bursts, cortisol is perfectly fine and keeps you alert. But chronic, relentless elevation actually damages the hippocampus. It shrinks neural networks and actively suppresses the birth of those new neurons we just talked about.
It essentially poisons the biological soil where the new neurons are supposed to take root and grow.
Precisely. Add systemic inflammation from poor metabolic health and the social isolation that often accompanies aging, and you create a perfect storm for neurological rigidity. We evolved to handle acute, intermittent stress, like running from a predator, not the low-grade, relentless anxiety of checking emails at midnight or worrying about the economy.
which brings up a slightly terrifying but profound realization. We are living in a society that demands constant, high level mental output but provides almost zero biological recovery. If we don't actively protect our brain's plasticity, we are basically surrendering our cognitive youth by default.
We are. But the beauty of the brain being adaptive software is that we can also hack the system in our favor. We can reverse engineer the environment to stimulate growth instead of decay.
Let's talk about those interventions, because this is where the science gets incredibly optimistic and actionable. Physical movement seems to be one of the most powerful triggers for brain regeneration. I've seen researchers describe exercise as literal neurological medicine.
And they aren't exaggerating in the slightest. When you exercise, especially aerobic movement, your body increases the production of a molecule called BDNF, which stands for brain-derived neurotrophic factor. Think of BDNF as high-grade fertilizer for your brain. It promotes the survival of existing neurons and actively encourages the growth of new synapses.
So, going for a brisk run or a swim isn't just about cardiovascular health. It is literally bathing your hippocampus in growth factors. It's almost as if the brain is wired to believe that if the physical body is moving, it must be exploring new territory, which means it needs to be sharp, adaptable, and ready to learn to survive.
That evolutionary perspective is spot on. Physical movement signals the biological need for cognitive readiness. And that ties directly into the second major pillar of maintaining a youthful brain, novelty. The brain absolutely thrives on doing things it has never done before.
Like learning a completely new language, picking up a musical instrument at 50, or even just traveling to an unfamiliar place where you have to navigate new streets. It forces the brain out of its highly efficient, energy-saving autopilot mode.
Exactly. When you do the exact same routine every single day, your brain becomes incredibly efficient, but it also becomes rigid. Novelty introduces a productive struggle. It forces the brain to encode new patterns and strengthen synaptic connectivity. Curiosity isn't just a charming psychological trait, it is a biological imperative for a healthy mind.
It really makes you question the whole societal concept of retirement, doesn't it? Society tells us that later life should be about slowing down, resting, and stepping back from complex challenges. But biologically speaking, cognitive stagnation is the fastest way to weaken your adaptability. We shouldn't be retiring from challenges. We should be actively seeking out new ones.
That is a profound paradigm shift. The absence of challenge is actually a threat to the nervous system. The brain requires meaningful resistance to stay sharp, just like a muscle requires resistance to stay strong. When we remove the friction of learning, we inadvertently signal to the brain that it no longer needs to grow.
This completely changes how we need to look at the future of longevity and aging. It's no longer just about preventing disease or trying to stubbornly hold onto the past. It's about sustaining adaptability. With the rise of advanced health intelligence and wearables, we are finally getting the tools to track our sleep, stress, and recovery in real time. But as the saying goes, the data itself doesn't improve health. The interpretation and the subsequent action do.
Absolutely. We are entering an era where we can actively monitor the precise variables that support neuroplasticity. We can manage our stress biology, optimize our metabolic health, and purposefully inject novelty and movement into our daily lives. The technological tools are there to guide us, but the internal mindset has to shift first.
And that mindset shift is deeply empowering. The idea that aging means an inevitable mental surrender is perhaps the most dangerous myth humanity ever accepted. Our brains were not designed to simply expire after a certain date. They were designed to evolve continuously, to adapt, to rebuild, and to rewire based on whatever environment we place them in.
So the ultimate question isn't whether your brain will change as you age. It absolutely will. The real question is whether you will be the active architect of that change, providing the curiosity, the movement, and the challenges necessary to keep it alive and growing, even decades later.
A brilliant and inspiring thought to end on. The aging mind is not a fading photograph. It is a vibrant canvas that is still actively being painted. Thank you for joining me in this exploration of our incredible, ever-evolving brains. Until next time, keep moving, keep questioning, and never stop rewiring.